As you transition from second to third level education through to graduation, you have an enormous amount of choice in courses and career paths available to you. But there is also a lot of confusion in the sea of CAO course codes, locations to study, accommodation that you need, and buzzwords that are used in course descriptions. It is easy to be overwhelmed and you can lose your way. This short video focuses on the discipline of control and automation engineering and gives you an opportunity to see if it is for you. We at TU Dublin and at our school hope it helps you make an informed decision in the courses you want to select. Controls, which is also known as control system engineering, is one of the few disciplines that ties many other disciplines together. The discipline of controls itself is a collection of control theory, a toolbox if you will, that we can reuse and adapt to many areas of engineering and well beyond. In this wonderful illustration by the engineer Brian Douglas, you can see it touches on various parts of the theory. It shows control methods, where the actual system is being controlled automatically. System analysis, where we examine margins of safety, the stability of the system, and the performance of the approach we've taken. The modeling and simulation, where we may have digital twin of the process or use simple block diagrams to model the system. State examination, where we examine the different transitional states of the system. And planning, where we plan in a sandbox how the system might be realized and then identify different control theory tools that might be used. But the true power of the control theory becomes alive when it is combined with other areas and other disciplines. For example, an electrical engineer might be designing an electrical distribution system with a requirement for low harmonic noise or an overvoltage protection system. In electronic systems, there are electronic circuits, microprocessors, microcontrollers, and the whole Internet of Things is based on this. So it is a fundamental skill to identify system stability. Industrial engineers using automation and robotic arms. Network engineers may use control theory to balance the operation of nodes to communicate information and data between different systems. In communication engineering, it may be used in the design of amplifiers to transmit signals and track satellites. Other areas such as the green energy space relies on controllers and control systems to run boilers, renewable energy, solar panels, and transmit information between intelligent automated vehicles, AGVs, to help with routing of the traffic. Mechanical systems may want to dampen vibration in machines using motor mountings or control sophisticated equipment used in manufacturing. In civil engineering, control theory might be used to dampen the movement of tall buildings due to the wind flow passing the building, or the integrity of bridges, or control wastewater or water treatment plants. Software engineers use control theory for controlling software processes. Aerospace engineers use control theory to model the aircraft control, collision avoidance, and make flights more comfortable within variable weather conditions and stiffness of aircraft. But the use of the control theory does not stop in engineering. Control theory is also used in business rules, economics, banking, ATM machines for dispensing and lodging cash, automation of stocks and shares trades to improve efficiency of banking products and decisions. It is also used in traffic control and stock management in shops. These are just a few examples on how control theory and control analysis tools are reused and spans across many different disciplines. To put it in a straightforward language, any process that produces an output based on inputs is considered a control system. It's that simple. Here is a simple example that might help you appreciate the concept. You have a garden that you're proud and passionate about, so you install a tap and a water hose to hose the garden. Every morning you turn on the tap for a period of time to water the garden. This is in essence a control system where the output is the wet soil and the input is the turning on or off of the hose manually. Now let's broaden the example. Say you install a Bluetooth controlled water valve. They're available on Amazon. Then, using an app on a mobile phone, you can turn on and off the valve from anywhere in the world. A wonderful thing the Internet of Things is. But say on a hot day you forgot to turn on the hose and your favourite flowers dehydrated. Or perhaps you were away on holidays and got distracted and forgot for a few days. The result will be very poor growing conditions in the soil. On another day, when you're away, the rain came and you also turned on and off the tap remotely as well. Obviously, the overwatering of your garden would not be a good thing either. If we installed a water sensor that had the ability to turn on or off the tap at different levels of moisture content and ensured that the correct moisture level was always reached. Hey, this is a jackpot. This is a closed loop control system and it would do the trick. But let's not stop there. Say the water during the full sunlight means that the water evaporates off the soil before it is consumed or absorbed by the soil. So we will need to add in a lot more water. So now let's examine the research. And also the watering in the evening time, just at dusk, is the best time for soakage and allows sufficient time for the nutrition to be transferred to the soil. So by adding in a light sensor, we can determine when the day goes from a bright to a dark phase and automatically turn on the water if there is not enough moisture in the soil already. We can also customize our water supply to particular seasonal growth patterns, and in the winter our theory is that there is less moisture required by the garden as there is less growth. And then we have the ka-ching moment. This allows us to have the best growing environment for the garden while being green and while using as little water as necessary, and it's all done automatically for us by a control system. But here's the challenge. We were just starting off as a simple gardener watering our gardens. Now we need electronic sensors, perhaps using solar cells. We will need Wi-Fi connections to the tap. We will now also need to put in place a place to store the rules and a system to run this control system for us. That is why a lot of control courses include electrical and electronic modules. We use computer software, we use a lot of maths, and we need to understand the actual growing cycle of the process itself to make it work to our benefit. We hope that this has helped to explain the subject of control systems and automation engineering and what is involved in the modules used on the courses.